Now, I don't have stock in Coca-Cola, but I sure use them a lot. This is the top. You'll see this in action in a minute. This is the top of a 2-liter bottle of Coca-Cola. I've developed a process of generating planets and stars with sound waves on the surface of a Coca-Cola bottle, with Coke in it, of course. Dr. Pepper worked as well, so if you're listening, Dr. Pepper. What you'll notice there is a depression. That was a strong hint, wasn't it? What you'll notice here is a depression on the surface of this liquid. Now, in school, you're taught this is surface tension that holds that little bead up. If you've watched rain fall down in a puddle closely, you'll see that splashes will hit a puddle and little tiny bubbles or spheres will dart around very quickly on the surface and then be absorbed and disappear. And they tell you, well, that's because momentarily the surface tension of the puddle kept that raindrop from actually falling through the surface. That's not exactly correct. As I showed you earlier with the drops, splashes, when a drop is formed up like that and spins like that in the air, it is spinning, it is convecting like a mushroom cloud around an atom bomb. You don't see it here, but that little drop of Coca-Cola there is spinning like that at high speed. But if you do nothing except generate that and then stand back from the Coke bottle, about 15, 20 seconds later, it will just reabsorb into the surface, pop, and disappear. But if you add sound to it, which we'll show you in a minute, you can keep reinforcing that spin and have it there indefinitely as a planet or a star or just a bubble on a Coke bottle, whatever you want to call it. But this is showing the same effect Einstein's equations predicted about the warping of the time-space fabric. That's the best way they could describe it. But you are seeing here, you're actually seeing it. Instead of an equation, you're seeing it. See what I'm saying? All right. Now, I'll pause on this for about 10 seconds. Okay. This equation here is the one I use to generate what you're going to see in a minute. There's a yellow, a green, and a red equation, and these are the constants I plugged into those to show you how the divergent wave and the convergent wave add together to give you the yellow thing. Now, I put this up primarily for the people who are going to see this DVD elsewhere who are of that bent, to show that this is the first approximation of the equation, definitely not the equation for our solar system, but close. Okay? All right. Now this is something that I will play again for you. Here is one waveform, that big hump that we saw at the beginning, and another one just like it moving in. In our solar system, like all stellar systems, the center of the sun is not in one place. They're separated by a number of miles. It's called an elliptical orbit, and there are two centers to the orbit, and so the sun actually rotates around 2 points like a parabola. When you get them real close together like they are, these waves start to add together. I got to cheat here for a minute. Where is my... Okay, let's try this and see what happens here. Okay. You see how they added together and formed that big hump? I'll do that one more time. The two waves add to form a taller hump than the first one. Okay? This is wave addition. Now here are those equations in moving form. The bottom ones are the two reference ones, so the divergent, convergent, and the one in the middle, or the one at the top, the yellow one, is the resulting orbits, which can be vastly different than a normal series progression or exponent or hyperbolic curve. Let me just do this again. Look at this. See these ripples here. Now here is one that's only about 9/10 separated from that by its frequency. And this would be the sun in the center, and these would be orbits of planets. Well, now, here you see two humps. They're not quite aligned, and two more, they're not quite aligned. But when you add them together, an orbit almost disappears. Now, why is this important? As our star starts to slow down, which all stars do as they die, the rings around them where planets can orbit change, and orbits get canceled. And it's like, hey, you can't park there anymore. And that's why we think Venus Only one of our planets that doesn't have what's called a magnetosphere or plasmasphere, and it rotates backwards to everybody else. We think Venus either came in from an outer orbit or out of the solar system and as an interloper in a temporary orbit. Okay. Okay, this is going to annoy you for a minute. This is sound waves around 110 cycles, somewhere in that range. It varies as I'm doing what I'm doing. I'm going to show you how we have the bubble formed, and then at the very end, there's going to be a very quick flash. You will see two large spheres on the Coke surface and a little tiny one coming in, and then suddenly bouncing away like crazy. This doesn't happen because of surface tension. This happens because their spins are opposite. The little guy has got a spin that goes out like this. The big guy has one that comes the other direction. And so when they get close to each other, they bounce off. Not magic, not electrostatics, but just pure movement. Notice in this, that would be the sun, and this would be a planet. What is happening is the speaker, I've got on the table, you'll see that in a second as it moves down the shot. The speaker is generating a wave in the side of the bottle that is reinforcing this one here and keeping it alive. It is feeding it inertia, waves, like planets get fed. Now this is generating one of those balls. It'll pop up here in the lower right corner. Okay. There's no magic to gravity. It is motion in a fluid space. It is spin around a center or two centers, as the case may be. If you apply that to a saucer craft, you're going to see the following things. First of all, a single anti-gravity craft, I'll get to the details of how that works in a minute, but the craft itself has to have spin in its field. Even a plasma craft, which is charged air at high temperature, which moves through a magnetic field, forms a spinning tornado with the center of it right down the middle of the craft. That was the early days. And up and out over the surface wing and back in to form a convecting smoke ring. When it does that, it's just like when you run your hand through the tub like this or down a stream. As you move this way, in opposition to the movement of your hand, there's anti-curl going the opposite direction to conserve momentum. The energy you're putting into the water spins behind you, a turbulent wake in a boat or whatever. Now, the little green circles you're going to see here are an example of a craft generating secondary spin vortices around it in air, space, water, wherever it's operating. Craft in the middle, the white thing, the counterspin vortices outside. They won't touch each other because they are going in opposite directions between them. Look at that again. Notice that these arrows are in opposite directions. If they were to get too close, they'd push themselves apart like those two drops you saw on the surface of that Coca-Cola. Boy, Coke's going to owe me a favor. Okay, now, if they got too close to each other, even as a craft rather than secondary eddies, watch what happens. Oops. Both of those circles were spinning in the same direction, but they'll bounce apart. Look at that again. Both spinning in the same direction, but in between them, no. However, there's a trick to this. The gap theory. Nothing to do with Genesis, but anyway. Okay, if you space them correctly, they will actually lock together with a common shared vortex in between them like that. Watch that again. Now, it's fairly unstable with just two of them like this, as they tend to kind of orbit. Okay? Now, if I let them freewheel in space, two ships using that, this is what they'll do. They'll spin around and you have a hard time controlling them. So we go to a stable form, which is 3 and more in triangular additions. Okay? They will lock together. They won't go any closer like a flock of birds. They will lock together like that in those formations. Now,